All right, let's dive into one of the cosmos' most epic showdowns. We're talking about a clash between two celestial heavyweights that push the laws of physics right to their absolute breaking point.
So we're putting the densest object in the known universe up against the ultimate abyss. It's a battle of just sheer, unbelievable density versus absolute, inescapable gravity. And we're here to figure out who really comes out on top.
But before we get to the main event, we've got to meet our contenders. Let's see exactly how they measure up.
First up in this corner, the neutron star. Okay, try to imagine a star, way more massive than our sun, dying and collapsing in on itself. What's left is this, a stellar corpse, where matter is crushed so tightly it's making a final desperate stand against being crushed into nothingness.
And in the other corner, we have the black hole. Now, this contender isn't really an object at all, is it? It's a place. It's a region of space-time where gravity has already won the battle completely, and where all the rules of physics as we know them just start to fall apart.
So when you put them side by side, something really fascinating pops out. Look at those diameters. At their smallest, a black hole is barely bigger than a neutron star. But here's the huge difference. A neutron star has a max size. A black hole, its potential scale is it's mind-bending. It can grow to be billions of times the mass of our sun.
And just to really wrap your head around the kind of density we're talking about with a neutron star, get this. One single teaspoon, just a spoonful, of its material would weigh about 1 billion tons. That's like taking every single person on Earth and squeezing them into a sugar cube. It is by far the most compact stuff we know of.
So the big question is, which one of these titans packs the bigger gravitational punch? It's time for our first round. Let's get into it.
It all comes down to something called escape velocity, how fast you'd have to go to break free. From a neutron star, you'd need to be traveling at about a third of the speed of light. I mean, that's incredibly fast, but escape is theoretically possible. Now, for a black hole, the escape velocity is greater than the speed of light itself, which means the possibility of escape just vanishes. Nothing gets out, period.
And that threshold, that line in the sand, is called the event horizon. And you gotta understand, this isn't a physical surface you could touch. It's a boundary drawn in the very fabric of space-time. Once you cross that line, every possible path, every direction you could possibly go, leads straight to the center. It is the ultimate point of no return.
So when it comes to the arena of gravity, there's just no contest. A black hole doesn't just pull harder, it fundamentally rewrites the rules of the fight itself. And that makes its victory absolute.
But hold on, the fight is not over, not by a long shot. Gravity is just one weapon in this cosmic arsenal. The neutron star is about to strike back in a domain where it is the undisputed king. See, while the black hole takes the prize for gravity, the neutron star has this other power, an incredible observable force. It is, without a doubt, the magnetic champion of the universe. And it happens like this. As the star's huge core collapses down from, the size of a star to the size of a city, its magnetic field gets squeezed and amplified by an insane amount. This process forges the most powerful magnet known to exist. And at its most extreme, in a special kind of neutron star we call a magnetar, that magnetic field is over 100 trillion times stronger than Earth's. It's so intense, it can literally stretch atoms into thin little threads and cause star quakes on its surface that can, for a moment, outshine entire galaxies. Just incredible.
Okay, so we have our champion of gravity and our champion of magnetism. It's time for the main event. What actually happens when these two forces of nature finally collide?
Well, it begins as this deadly cosmic dance. As they spiral closer and closer, the black hole's gravity starts to stretch the neutron star, pulling it apart atom by atom in a process called tidal disruption. Then, in the final, violent moments, the neutron star is completely shredded. All its matter forms a brief, fiery disk before it's swallowed whole, sending out one last chirp of gravitational waves across the universe.
But here's the amazing thing. This incredibly destructive event is also profoundly creative. The collision can trigger what's called a kilonova, an explosion so intense it actually forges the heaviest elements in the universe. In fact, the very gold and platinum we have right here on Earth were almost certainly born in a cataclysm just like this one.
So after all that, after the cosmic dust settles from that incredible collision, it's time to announce the winner. Winner by gravitational knockout, the black hole. I mean, in a direct head-to-head confrontation, there's just no contest. The black hole's absolute reality-bending gravity wins every single time.
But, the story isn't quite that simple. The neutron star is the master of matter, of magnetism, of observable fury. It's the universe's ultimate warrior, just blazing with energy, especially when you compare it to the black hole's silent, invisible reign. So maybe the real question isn't who wins, but more like, what do they create? Are they just cosmic destroyers? Or are they actually essential architects in the universe's grand cycle of death and rebirth? Their collisions seed the cosmos with the very elements that make planets and even life possible. And their gravity shapes the galaxies we call home. So in the end, maybe their true role isn't about victory at all. Maybe it's about creation.